Okay, so this is going to be pretty similar to what we did, but it's going to add a layer of complexity. What I do want you to remember is the discriminant, right? Delta. So we're going to have a recap of that today. B squared take 4AC. And if it's positive, we have two solutions. If it's equal to 0, we have one. And if it's less than 0, we have no solutions. That's what we're going to be using here today, okay? So the discriminant, B squared take 4AC. If it's greater than 0, if it's positive, two solutions. If it's equal to 0, one solution. And if it's less than 0, no solutions. Now, we are asked here, here's f of x, here's g of x. Oh, it's got this m. M could be any number. And rather than finding the points of intersection with a particular value of m, we're told determine m such that it's tangent, such that it has one solution. When does one solution occur? When the discriminant is 0. So here's how we're going to solve this problem. We start by doing exactly what we did before. We make the functions equal to one another. Then what we're going to do is move this over to the left-hand side. So I'm going to take away mx from both sides and add 7. All right, so x squared take 2x take 3. This stays as it is. I've got take mx, and then I'm going to have plus 7. All right, take away mx, moves it there. Plus 7 moves it onto the left-hand side. All right, maintaining that equal to 0. Now I've got to collect like terms. And minus 2x and minus mx are like terms, but I can't really add them together. So I'm going to show you a way we can simplify it. What I'm going to do first is just write them next to each other. Okay? And then we have this minus 3 plus 7. We can collect them. Minus 3 plus 7 is going to be positive 4. Okay, so then, if we're looking along here, I want to show you how we can bring these together. What is common to both of these? X is common, so I'm going to pull x out the front, all right, and I'm going to write it in a few different ways. I'm going to pull x out, just pulling positive x out the front, and in brackets here we have minus 2 take m. All right, so I want to show you that not. If I distribute this, x times minus 2, that's going to give me the minus 2x, and positive x times minus m, that's going to give me the minus x. So that's all fine, that's legitimate, we haven't changed it in any way whatsoever. And then I'm just going to do one more thing, I'm just going to write it in a little bit of a different order, just because I'm really trying to demonstrate what's going on here. Okay. So all I did in this step was swap the x and this around the other way. All right, because when we have a quadratic, all right, we have ax squared plus b times x plus c. And so you can see what corresponds with A is positive 1. What corresponds with B? The reason we set it up like this is I've got all of B is inside that bracket there. That is the coefficient of the x term. Okay, and then what's the value of C? C is positive 4. So let's write those. We've got A is 1, B is minus 2 take m, and C is 4. So I think where people get lost in this is the factorizing of the x and simplifying it there. So maybe I'll just emphasize that one more time. All right, so we've moved it all across. All I did in this step was wrote them next to each other. Minus 2x take mx. I said what's common? X is common, so I pulled x out the front. And now that thing there in brackets, that's the coefficient of x. That's the b value. All right, that's my b. So now I'm asked, what's the question say? Find the value of m such that there's one solution. Find m such that there is one solution. Well, the discriminant is equal to b squared take 4ac. And one solution occurs when the discriminant equals 0. Alright, so this is what I'm asked to do. I'm asked to find the value of m such that the discriminant equals 0. So here's the ABC. I'm going to put them into the formula here. We have minus 2 take m. B squared take 4AC. Alright, we'll keep going here. I'm going to expand this using the perfect square rule. Alright, it's going to be a squared take 2ab plus b squared. So this becomes 4 plus 4m plus m squared. Then we have to take away 16. Alright, so perfect square, that expands to this. 4 times 1 times 4, that's 16, that expands to that. Alright, I'm going to collect like terms along here. I've got m squared plus 4m take, now I've got positive 4 take 16 minus 12. And we have another quadratic. We have a quadratic within a quadratic. So I'm going to go through and just keep going and solving this, and then I'll do a bit of a recap of how we arrived at this. Remember, what we're doing is we're finding the discriminant when it equals 0. Here's what the discriminant simplifies to. We want to find when the discriminant equals 0, so we need to factorize this quadratic, right? There are two values of m that multiply together to be minus 12 and add together to be positive 4. So 6 and minus 2. Positive 6 times minus 2 gives you minus 12, and positive 6 plus minus 2 gives you positive 4. So this factorizes to m plus 6 and m take 2. And so our solutions are m is minus 6. Let's apply the null factor law. M equals 2 or m equals minus 6. Okay, so we're going to do a recap here. All right, we'll talk about it, then I'm going to present it on Desmos and show you what those two solutions mean. So we have x squared take 2x take 3 is equal to this line. All right, we're saying m could be any value, but we want to find m such that it touches once. It touches once. There's one solution. You might be going, hang on, how come you've got two solutions then? Well, there are two values of m such that it touches once. I'll show you that in a moment. Now, what did we do? We've made it equal, we moved it across, we joined these together, all right, we identified A, B, C. We said in this circumstance, we want one solution, that's tangent, Noah, so the discriminant equals 0. We found the discriminant and we follow through to find the values of m. So that's what it is, bringing it all together. Let's understand it visually, okay? Here I've got the quadratic. This is what's good about Desmos is you can add these sliders, right? And I've got y equals mx take 7 where m is, I can adjust the value of it here. So what I want to show you is firstly, this is no points of intersection, right? Here at m is 0.9 or 0.4 or 1, we have no points of intersection. And then when m is 2, I'll have to change it, it's a bit fiddly. When m is 2, there's the tangent, okay? When m is 2, that was one of our solutions, we have one solution. The line is tangent to the quadratic. All right, but we said there's another value of m as well, minus 6. So I can slide it. All right, you can see, remember what is m for the line but the slope? Minus 6. It's going to be there somewhere. All right, tangent up here, touching, where's it touching? There. Okay, so this is going to be a little bit tricky. The variable is either going to be that term or that term. I've done the more complex circumstance where the variable is here because then you end up with another quadratic. A lot of the time you're just going to have a linear equation to solve over here, so they're not too bad. All right, but just quick recap again. Make the quadratic equal to the line, bring it all together. identify those values of A, B, C, and then find the discriminant. What's the circumstance it's asking for? If it's tangent, it means it's touching. It means it wants one solution to when these curves meet, right? And so we've gone through and found those solutions there. So, see how you go. This is a pretty challenging part of the unit. So let's get into it.
Question 2, 3, 4.